Let's make a few more points about dangerous anthropogenic interference from Oppenheimer. How large must a region be before food or water deficit counts in this dangerous anthropogenic interference? Are the various deficits commensurable? That is, does low food availability carry the same weight as low water availability or disease vulnerability? So I talked about food, water, energy, and health. They are, of course, related to each other, but we can think of them separately as well. People think of food security as a big thing without worrying about necessarily worrying about availability of water or safe health, right? So nonetheless, they have to be considered as different factors that may have to be considered in defining dangerous anthropogenic interference. How do multiple but modest deficits count versus a single extreme one? So let's say you have less than a required number of calories, amount of water, and morbidity higher than desirable, then do they add up to a DAI, or does one have to be beyond some threshold by itself? Do these deficits stand in isolation from other categories of risk? That's critical. Or does the Article 2 language on sustainable development imply rather that the entire context of poverty, wealth, education, and the distribution of these qualities and so forth that affect the ability to adapt needs to be taken into account to evaluate the danger? So I think you get the point. The terminology dangerous anthropogenic interference and those categories of unique and threatened systems, global distribution, extreme events, and so on they have value, but they are not necessarily covering all aspects at local scales that people are going through. Experienced danger versus these definitions, those are important. So looking again at components of external and internal definitions of dangerous climate change, this is the external definition and this is the internal definition. So there is the hourglass defining dangerous climate change, going from world development, obviously comes with increased energy use and greenhouse gases, global climate models and regionalization of the information, looking at impacts, and then vulnerability in terms of physical climate, and then physical vulnerability as well. And then you are going up from this side in terms of institutions, equity issues, infrastructure, information and skills, adaptive capacity, and vulnerability. So this is social vulnerability. So for a country like Bangladesh, for example, it is facing sea level rise issues. What is its adaptive capacity? What does it translate to in terms of its social vulnerability? Right? Just because it has all the information it needs to understand the challenges it's facing in terms of sea level rise and its impacts, let's say combined with cyclones over the Bay of Bengal, what can it do with it in terms of adaptation? Okay, so internally, experienced dangerous climate change is important. So indicators derived from legitimacy of the source of the information, whether it comes from governments or an insurance agency or scientists and so on. Behavioral change observed through markets or other collective action. Do people begin to invest in energy savings, more efficient appliances, move away from the coast, and so on? And the determinants include trust in regulators and other authorities, amount of information available, personal experience and recall. So extreme events, people begin to say this thing didn't happen in the last 100 years, like the Kerala flood of 2018, I think. It happened before in 1924, I think, and then it has happened in 2019 and 2020. So are these events happening more often? So the experience is going to matter. Values and world views. So how do you value dangerous climate change? Let's say there is a very culturally valuable site that gets trashed by a cyclone or by a flood. then how do you put that in the context of dangerous anthropogenic climate change? Okay, these are important issues. This is a little short, so let me go on. So in that context, we have to understand what is beyond prediction. Is IPCC SIMIFY models combined with, let's say, weather and climate models already serving all the needs? This is an article that came out in Nature, I think, and got tremendous attention in the media, where it said climate tipping points, too risky to bet against. The growing threat of abrupt and irreversible climate changes must compel political and economic action on emissions. There are unfortunately problems with this heuristic argument. This paper didn't do any new calculation. It just took published articles on extreme events and warming rates and other things and created argument for how tipping points may be closer than we think. The models, which are, let's say, IPCC process being handled by World Climate Research Program, is not directly involved in these heuristic extensions of what the IPCC models are saying. So one has to be careful there. And then there are papers like this which look at climate tipping elements. What are they and how worried should we be? Emerging Arctic ozone hole already has a large interannual variability. Disintegrating West Antarctic ice sheet. Antarctica is a complicated story because ocean warming is melting ice shelves from below, whereas warmer ocean is increasing snowfall in some places. So what are the uncertainties there in saying if and when this could happen? And what would be the impacts? Are we even capable of saying that? Collapsing deep Antarctic circulation. This is likely not going to happen as far as we know from models. So melting Greenland ice sheet. This is great worry. It's accelerating and processes are not looking good. And in the warming phase, we know that ice albedo feedback can produce abrupt changes. So one must watch out for these. But what does it mean in terms of the rate of melting and rise of sea level in the coming century or longer? And what can be done about it, really, in the end? That's the question as well. Shifting tundra, dying forests, as I already mentioned, El Nino remains not easily explained in terms of how it has changed with warming in the past, and whether it has actually changed much in the Holocene, for example, when we look at evidences from corals and so on, and what it will do in terms of the mean state of the tropical Pacific, in terms of the east-west temperature gradient, if you know those details, and what it means in terms of global warming and El Nino response to global warming or ocean warming and atmosphere warming and climate change in terms of its intensity, duration, patterns, frequencies, etc. Okay. Other things: dying Amazon rainforests, greening Sahara and Sahel, chaotic Indian summer monsoon, and so on. Of course, these are big issues, but it is very different than saying what trends are there versus whether they are heading to a tipping point. Okay, that's not an easy challenge right now with the ability of the models, the process understanding, not just what models can do, but what do we even know about them from fundamental science perspective. So, complicated issues.